Mm. What's up, YouTube? Good afternoon. So I'm Greg from Greg's Tutoring NYC. I'm a tutor in New York City, and I'm going through a little series here I'm calling Hardest Math Problems. So what I'm doing is taking the perspective that the hardest math problems I'm pulling from the New York State tests from past years. Um, there's other ways to define what a hard problem is, but a little series here I'm calling hardest math problems. So what I'm doing is taking the perspective that the hardest math problems. All right, we're live. We already have. One second, guys. We have spammers. Okay, a little silly cat and mouse game we go on. There's people trolling. So, again, welcome. This is Greg from Greg's Tutoring NYC. So we're doing this a series on some of the hardest math problems. I'm choosing to use the state test as our guide here to define what hard is. So what I've done is gone through all the past years of state tests and figured out which are the harder problems. And those are the ones we're going to take the perspective on. There's different ways to look at hard and different ways to define hard. This is the way I'm taking it. This is kind of a precursor because next week is the New York State test on top of that. And even though we're focusing on New York State questions here, this is not about New York State. Today we're doing grade 5, so there actually may be a part 2. There's a lot of problems today for this. It kind of bumps up a grade 5 to be more complex. So that's the situation we're in there. So we're just going to mosey along with some of that. This should apply to basically any grade 5 student, though. Some standards and some curriculums kind of wiggle back and forth on a few topics. We're not going to really worry about that because the truth of the matter is a grade 5 student in May, we're in May now, should know all of grade 3, all of grade 4, most of grade 5, if not all of grade 5, and even some of grade 6. So even though the topics can wiggle back and forth, your proficiency should be wiggling back and forth as well too. What we're also going to be doing is looking at not just problems, but how to solve problems. That's always my focus, because math is about thinking things through, reading the questions, understanding them, figuring out what needs to be done, stuff like that. All right. So I already did a grade 3 and a grade 4 one, so you might want to review that, guys. And I'll put links in at some point, pointing them all to each other. Again, I'm a tutor in New York City. I tutor for a lot of stuff. I mainly tutor for high school admissions, but I also tutor for a whole bunch of standardized tests, including elementary grade school admissions like the ISEE and the SSAT, and also for admissions to high school and even stuff like the PSAT and the SAT and the ACT. So there's a bunch of places I go, and even though I'm New York City based, I also know about like admissions to Boston's high schools, admissions to a whole bunch of high schools in New Jersey. I even help kids with admissions to high schools in New South Wales, Australia, stuff like that. So with that in mind, let's try to just jump in here. Let me get rid of this window here. One second. Why is it not coming up? Okay. So here's where we're going to start with. And actually, just before we start, there's something that gets a little more important at this point, and that's reference sheets. So at least in New York, they put this as just before your test happens. Okay. So there's a whole bunch of conversions you should know. You shouldn't really be relying on these reference sheet papers. This is stuff that becomes rote and memorization, just like memorizing your multiplication tables and stuff like that. It is a pain in the neck, but it is part of learning math. I don't like to focus on these parts of these things because, again, as I said earlier, I think math is about problem solving, it's about critical thinking, and it's about understanding problems and trying to present solutions. So, but the truth of the matter is you still need to know certain things. You must know your multiplication table. You can't go through grade 5 math counting on your fingers anymore, all right? You really should have learned it before grade 3, but grade 3 is normally the grade where you're told you need to be proficient in it. At least up to 10 by 10 and hopefully up to 12 by 12. As you get into other grades after this year, you should be going to basically 20 times 20. You should know your perfect squares, and you should know teens like 15 times 16, 15 times 17. But for right now, for grade 5, I wouldn't necessarily, worry about that super duper. But you should definitely know 10 by 10 or 12 by 12 up into that table. And if anybody has a problem trying to do something with that, I could teach you techniques as well if you email me. My email keeps flitting across the bottom, GregsTutoringNYC@gmail.com. So all of you should know that a mile is 5,280 feet. You should know that a pound is 16 ounces. You should know that a cup is 8 fluid ounces. And that table on the side there, you should be proficient in. So this is the extent, and this page gets included to every tester. So this that I'm circling right now, you should know all your volume conversions, what a cup is, what a pint is, what a quart is, what a gallon is, okay? And they're also giving you a formula down here, okay? That you should know the volume of a prism, which implies that you should know the area of a rectangle too, okay? You should know the area of a square, right? You should know the perimeter of your shapes. You should know all your geometric shapes up until with polygons of sides 3, 4, 5, 6, 7, 8, 9, 10. If you can get all those down pat, first of all, you're gonna be tested on them repeatedly, and you need to have. So we're talking about being numerically fluid. Your numeracy is what we're shooting for here, right? If your goal is to master these topics, all right. So these are things that you should be very familiar with, committed some to memory. If I tell you 2 times 2, you should know 4 immediately, right? But you should also know like 8 times 8 just as fast, okay? And there's also, when we talk about fluidity, if I tell you 12 times 10, you shouldn't need to go to a calculator to do that. You should just know, oh, I add a 0 to the end of that, all right? So this is what we're looking at here, and this is what we're trying to figure out. Because as we go through these problems, and they're going to get harder and harder as we go through more and more grades, and there's going to be a few tough ones today. If you have a complicated word problem, you still need to figure out what the math for that is, and then still do the math. So there's layers that you have to peel off of here, and you don't want to get caught up in doing 12 times 10, and you don't want to finally understand how to process it and critically think it through, and then get something like a silly error. And even silly errors are not silly. They're pretty consistent across students, and it still means you haven't mastered it. And certain kids get certain things wrong repeatedly, and this is something a lot of teachers can't catch because it's not that the teacher's incompetent, although some might be, but they have 30 kids to deal with, and the teacher may also have 5 classes. So it's hard to keep track of exactly what skills every single kid has down to the finest detail, especially on something like grade 5. You're teaching 150 kids, that's a lot to process and keep track of for the kids. Even if the school does assessments and so on, some stuff can still slip under the radar, okay? So you yourselves as students need to start learning what is your strengths and what is your weaknesses, and trying to balance the two back and forth, and increasing both. If you're strong on something, become stronger. If you're weak on something, absolutely become strong on it, right? So you're going to bump up your game no matter where you fall in the realm of the situation. All right, so this is the extent of the reference sheet that they give you from New York State. Your states will give you similar reference sheets, and this is basically one of the criteria that they're going to judge you on. Now, many state tests will not say like how many ounces is in a pound, but this is still something you need to know. So definitely those top lines here. A mile is 5,280. Okay, a pound is 16 ounces. Okay, stuff like a ton and a mile per yards, that doesn't come up as much. But on that same note, if you see what's not here, right? What's not here is like inches to feet, feet to yards, because this is pre-grade 5 stuff. But a lot of you still don't know that this 3 feet in a yard, right? And I believe this is the problem in the set today that involves having to know that, or how many inches is in a foot and how many inches in a yard. And you should be able to take all these conversions that you know and figure it out. If I asked you how many inches is in a feet, you should know that through all the different conversions you have. The same over here, if it has a gallon, it's 4 quarts, then how many cups is in a gallon? You should be able to use the info on this table right here to be able to calculate that. And that there might be a word problem that's in gallons, and the final question is how many cups is that? So there's a second layer on it again, right? So there's all these kind of things that are going on. So let me bring up another reference sheet, which is something I give my students, and just to show you kind of some of the categories that you should be familiar with. Things like time. There's 365 days in a year, and I have a little comment about the exact details of that. And there's 52 weeks in a year. A lot of kids still don't know how many weeks in a year there are. Okay, there's more esoteric things like a score, that's 20 years, but you should all know a century is 100 years. Okay, and you should also know a millennium is 1,000. Okay, here's what I was talking about before. You should know a foot is 12 inches. A yard is 3 feet. So that means 1.5 yards is 18 inches. And a lot of standardized tests, things like 18 inches and 1.5 yards, they come up a lot. So you should know this unit conversion. The same with the mile. And normally when they give the mile thing, they actually tell you the number. But you should just know it, okay? You just also know your meter conversions. And by meter, I mean kilometers. I mean, it could be capacity, it could be length, it could be weight, right? Because it's all going to work that you have centi and milli, okay? And the key is that it's 1x equals 1,000 milliXs, okay? And it works for whatever it is. It could be one liter equals 1,000 milliliters. 1 meter equals 1,000, and kilo goes the opposite way, right? Milli is greater than 1, kilo is less than 1. So anyway, I have details here. My goal at this point is not to teach you unit conversions right now. There's also weights. So we saw the weights earlier. There's also conversions involving grams. There's also groups. You should know a dozen is 12, and a gross is 144. Gross doesn't come up a lot, but if it's there, you should know it. And in any event, 12 times 12 comes up a lot. So it maybe not matter as much that you know that's called the gross, but that's what it is. Here's some of the capacities, okay? And you should know that a liter is a capacity. It's not a length. It's a length of volume, of course, but it's not a length like in inches, okay? And I have some other explanations here. If anybody wants this file I'm showing you right now, you can email me. The email is at the top here, GregsTutoringNYC@gmail.com, and I will send you this PDF, okay? Because this is stuff you need to know as a 5th grader and in your day-to-day activities for the rest of your life anyway. Like, how could you not know this 52 weeks in a year, whether a century is 100 years? These are things that come up often in day-to-day stuff, and certainly in your math questions and math problems. What I suggest you do, just like with the multiplication table, is if you save this on your phone, let's say, as a JPEG or something, just every morning when you wake up, look at it. Every morning when you go to sleep, look at it. Every morning when you're eating breakfast, look at it, right? Just pick a certain day. It used to be a good time to do kind of stuff like this was when you're on your way to school on the bus or the train, or even in the backseat of a car, right? Now that everybody's remote, that's not happening as much, but just pick a time. It could be when you're eating lunch. It could be after you're going to do something. You have a favorite TV show at 8 o'clock, so at 7:45 every day, just pick at this. And then the memorization becomes easier, and it becomes fun, becomes less mundane, less boring, all these kind of things like that. All right, so that's a key issue on some of this too, in addition to taking the questions and ripping them apart into pieces. All right, let me just make sure we're still live. Yeah, we seem to be. All right. All right, so let's go back to the first question. So a lot of questions are laid out in this form where there's kind of a statement, the top line there, and then a bunch of bullets, and then finally the actual question that you're going to be asked that they want you to present a solution for. All right. So what I find is if you progress through this kind of list, one bullet at a time, and resolving the math that needs to be resolved at each bullet, that you'll build up the answer so that when you finally get to the bottom where you need to be, you'll have the answer. Now, this question almost all kids got wrong. So I'm not sure why. I don't have that analysis, but I just know a lot of kids got this question wrong. So let's just go through it. So the 5th grade class, so a lot of kids think this is 1 divided by 5. It's not. They're talking about grade 5. A grade 5 class at Brookfield School used 5 identical buses. And this is a technique that they use on these tests too, is like there's a 40 here, 40, but 5 buses is FIVE. So they'll mix the actual numbers as with digits with the number as a word, okay? Because you're told often to underline these things. You're not just underlining them just because you can. You're kind of poking your brain. You're tapping your brain on the side like, this number is probably important. And when it's a word, your brain tends to skip over it. So if you underline it, there's 5 buses, okay? So that's what I get out of this. The grade 5 went on a trip, okay? And they used 5 buses, okay? There were a total of 40 seats on each bus. So we don't know what's important yet, but I tend to think that even though you can be given a question with information that's not useful at all, normally, at least in New York, and I have experienced a lot of other tests, they don't seem to be trying to trick you by giving you information that you don't need. It does happen, but it doesn't happen as much as you think it does. So what I'm going to do is just go and iterate through each of the bullet points here. There's 5 buses with 40 seats on each. Okay, so that means there's 40 times 5 seats, or 200 seats in total. Now, this may not be important information. We don't know exactly what they're asking us yet. Okay, and then, by the way, another way to approach this is to read it through, to kind of grok it, and I can actually read it through fast. Since so many kids got this wrong, that's not necessarily going to help a lot of you because it gets too busy and your brain gets overloaded, right? You have your long-term memory where you put stuff like memorizing the multiplication table, and you have your short-term memory. Your short-term memory is going to process this question, and you're going to read it, and you never can care about this question again for the rest of your life. It doesn't really matter. So you're going to overload it. It's like if I told you my telephone number right now, it's only seven numbers, but most of you will not be able to repeat it as soon as I told you. Or if you repeat it, you repeat it instantaneously. But if you wait 5 or 10 seconds, you're going to get at least one of the digits wrong. So that's the kind of problem with this. They're throwing a lot of data on this question, and it gets too busy. And some of the data is words, like 5 buses, and some is numbers like 40 as digits. All right, in any event, there's 200 seats, okay? It says all of the seats on 4 buses were filled. So that means we have 40 times 4, or 160 seats were filled. So there's 5 buses. 4 of the buses have all their seats filled, okay? All right. The 5th bus has 4/5 of the seats filled, and that means its seats filled, right? But sometimes they use vague kind of pronouns or terminology here. It's talking about 4/5 of the seats on the 5th bus, right? We already had 5 buses. We already compensated 4 of them at this step right here. And the last bus has 4/5 of its seats filled. So that's 4/5 of, right, of 40. And of means multiplication. When you see of, it normally implies multiplication. Okay, so we can do this, right? So we can do 4 times 40 and get 160 over 5. Okay, if we divide 5 into 160, we'll do it over here. Okay, 5 goes into 1, it doesn't. 5 goes into 16 3 times. And we get 1 left over, right? So we get 2 there. So that's equal to 32, okay? And if, my tablet keeps not drawing these things. And we can double check that. 5 times 32, 5 times 30 is 150. 5 times 2 is 10. We get 160. So that's cool. And by the way, there was another way to do that multiplication. So if we had 4/5 times 40, right? We notice there's 5 goes into 5 once, and 5 goes into 40 8 times. So we're left with 4 over 1 times 8, and that's also 32. Okay? So that means so far we had, we had 200 total seats. That's our total. We have 160 on the one bus. We have 32 on the 5th bus, right? Because there's still a fifth of the seats. That means we used 192 seats. Okay. And then finally, this last bullet here, it says 1/8 of all the passengers on the buses were adults. So all the passengers of the bus is 192. And 1/8 of them, so we're going to divide that by 8, right? 1/8 of 192 is that. So we get 192 over 8. And that's what we're going to do over here. Okay, so we do the division. 8 goes into 1, it doesn't. 8 goes into 19 how many times? Twice. That gives us 16. We have 3 left over. 8 goes into 32 4 times. Okay, so that's how many adults we have is 24. So we processed the original statement up here. We went through each bullet point, and this is busy as heck. There's a lot of calculations going on here. And then finally, the question is, how many adults went on the field trip? We just answered that as 24. Okay. So this is so busy. What I like to say is to reread the problem and feed the answer back into it. This has so many steps that feeding the answer back into it is hard. And this is fairly straightforward. I normally like to recommend solving a problem a completely second way, but with this problem that's pushing it, because if we took each bullet in turn like we did, it's an kind of an iterative, incremental progression through it. And that's how I like to solve these problems. And normally, some of the distraction information is important. So it turned out that this item here never really became important. It wasn't important that there were 5 buses and 200 total seats. That never came into play. Okay? We could have done something else maybe to do that calculation, but that would have made this super duper harder. All right? So this is a hard problem. And by the way, as I'm going over these, before I start solving the problem, you may want to pause the video. I see there's a bunch of people out there live. Howdy. How's everybody doing? Hopefully you guys are doing well. Let me see here. Wait a second. I just got a message too. Oh, it's about voting. Okay, so that's the details there. This is actually a fairly complicated problem. It's also a time waster. This is a lot of time because there's a lot of calculations going on here. And you don't want to make one slight goof up. If you notice the answers like 24 and 25, they're pretty close. And a calculation that you got wrong when you're doing the bullet processing could be enough to get you the 25. And like I said, this is a question where it's hard to take the answer and feed it back in. Okay, this is also even hard to redo a second time. The only good news is sometimes they leave a space underneath it. Okay, this is not the actual test paper here, so even though you're seeing a space below this, it's not necessarily what was presented on test day. So this is a tough one because if you already scribbled a whole bunch of stuff on your test sheet, it gets to be annoying to try to do a problem like this a second time. Technically, you should be able to ask for scrap paper if you ever need it. This also gets even a little more complicated because some of you are taking your exams on a computer where you don't have the capability to really, some of them let you do highlighting with a virtual marker, and some of them let you put a little notepad and you can do notes. Some also support doing arithmetic calculations through a kind of a smart notepad that understands math. And some even provide you a calculator. But at the end of the day, if you can, you should always do a problem like this on paper. Okay, and if you notice, I wrote down everything. That's a key to solving a lot of these too. So that if you happen to make a mistake and you just look through it slowly, you can kind of figure that out. So this is the kind of problem, by the way, that you don't want to do fast. So it's a time killer, first of all, and then you don't want to do it fast anyway. So it's like a double time killer. And on the other hand, this is the kind of problem where if you just do it each step at a time, it can make logical sense and you can get the right answer fairly consistently, even though a lot of kids, most kids who took this test got it wrong. Okay. I'm assuming some of them didn't really understand the 5 buses versus 4 of them completely filled and 1 had 4 fits. And some kids get confused enough because there's enough numbers flying on this page that, like on the bullet point here where it talks about 4 fits, they'll take 1/5 or something like that. Or they wouldn't know what to subtract. Like I added the 160 and the 32 over here. Some kids start getting confusing and they subtract that and get 128 instead. Okay, and then they get 1/8 of 128, which is starts tethering to answer number A. Or what happens is there's so many calculations on this problem that if a kid got 23, they might just say, you know what, the answer is 24. Or if a kid ended up with 19, is okay, the answer is 20. Because at that point they don't know how to solve this. So it's key to do things methodically, almost robotically. In fact, this one I mentioned earlier in the beginning about critical thinking. This problem is actually not critical thinking. This is just following each bullet, doing the calculation for each bullet. Okay. You probably want to peek at the question too. I mentioned just following this along, but if you know the ultimate goal is to figure out how many adults, and that means how many total adults, not on the 5th bus, not on the first 4 buses, on all 5 buses, right? So, and by the way, another way to have done this was to figure out there was 200 seats, right? And 1/5 of 40, if we concentrate on here again, 1/5 of 40 is 8, right? So we could have done that calculation the same way. In other words, 200 minus 8 is the 192. So technically there was a faster way to get that. Okay, so there's a kind of halfway to do this double check using an alternate way and actually using the number on the top here. All right, so I'm modifying as I'm analyzing this a little deeper. There is kind of a better way to do it. So, all right. Okay, to change the tune completely, this is another kind of busy problem. So there's a whole bunch of equations, and I like to say, let's look at the illustration first. but there's just a lot of busy equations they're throwing at us. So you throw it as 4 equations. They all seem to involve a denominator of 10 or 100, and they're adding each one. Each one has a plus, one fraction plus another fraction. So this is decimals, this is factors of 10, and this is fraction addition on top of it, okay? And normally when a question is set up in this form where there's a bunch of equations, they're going to ask you to compare them at some point. It may be asking which is greater, or they're going to ask you something like they eventually do here, is which equations are true, okay? And if you notice, if you look at the choices, the first 2 are only looking at one equation being true out of the 4, and C and D says that 2 of them might be true, all right? So what's happening here is this question is actually forcing us to do this computation on each one of them. So again, this is why it's kind of slow, whatever. So this also not only becomes a factors of 10 and 100 in fact addition, but it's about least common denominator and stuff like this, common denominators. So the easiest way to do this, because we know we have to compare all these now to each other, and at least see which ones are true or false in isolation, and then together, which of them were true out of all of it, okay? So if you convert 3/10 to have hundredths, okay, that would be 30. Okay, most of you should absolutely know this, because we're trying to shoot for the 100 over here. So we're going to convert the 3/10 to hundredths. We multiply the denominator by 10. So whatever we multiply the denominator, we multiply the numerator. So if we multiply the denominator 10, we multiply the numerator by 10, and we get 30. Okay? So then we have 30 hundredths. We can kind of almost cross that out. And we end up with 45 hundredths. Okay? And it says 18 hundredths. So equation 1, if we did it correctly, has to be wrong. Okay? 2, we have the same thing. The answer's in hundredths. The second fraction's in hundredths. So we're going to convert the 4/10 to hundredths. Same thing. Whatever we do to the denominator in multiplication or division, we do to the numerator. So multiply the denominator by 10. We're going to multiply the numerator 10. So we get 40. Okay, we can get rid of the 4/10 at that point. So 40 plus 32 is 70. So this one's good. Okay. The next one has the same thing. We have 100, 110. So we're going to make that multiply the denominator by 10, multiply the numerator by 10. And we get 72 over 100. So that says 27. They flipped the digits. Okay, so this is no good. Okay, and then the same problem, we have 100, 100. So we're going to make this 60 over 100 instead of 6/10. And 60 plus 27 is 87. So that's good. So if we did this correctly, 2 and 4 are good, which gives us D. Okay, so again, it's busy. There's a lot going on here, right? And so on. By the way, I see some people coming in and out. Welcome. Please, this is interactive. That's why I have a chat going. So feel free to comment or ask questions. And if you're a little more introverted, you can certainly email me, GregsTutoringNYC@gmail.com. Please subscribe. Please like. I do a lot of videos, and I'll be doing more of these, so that even if you're in grade 5, next year you're going to be grade 6, there'll be one of those up here too at some point. And again, please ask questions if you like, and share the link. All right, so I think that's the only other question left on this page. I'm going to go about an hour. I think there's too many questions, so we're probably going to do a part 2 of this. Okay. Okay. So we have a word problem. Min wants to make 100 name tags with ribbons attached to them. Each name tag requires 5 centimeters. So again, they're doing that. They're writing numbers like 100 with digits, and they're writing other ones like FIVE with words. Okay. She has 3.25 meters of ribbon. Okay. exactly how many more centimeters? How many more centimeters does she still need to make 100? Okay? So this ties back to what I was showing earlier. If we go back to, say, here, I think it was. No, it was well, we have an example like this. 1 liter equals 1,000 cubic centimeters. So 1x equals 1,000 center x's. So in our case, that's applicable because, whoops, where did that problem end up? There we go. Because if we use that logic, then 1 meter equals 1,000 millimeters, I should say. And I like to remember this because if I remember that one, all the rest come into place. Okay? So that means, because I already know that centi means 100, so this also means 1 meter equals 100 centimeters. Okay? And it also equals, because a dime is deci, as in decimal, is 10 decimeters. So I just remember the first one, and the rest just kick in for me, no matter what it is. So this is 1 meter, it could have been 1 liter, right? 1 liter equals 1,000 milliliters equals 100 centiliters equals 10 deciliters. Okay, it works for every denomination. Same with kilo, right? 1 meter is 1,000 kilometers, or 1,000th of a kilometer. So it works backwards on the other one. So anyway, if she has 3.25 meters, as we say here, right? Okay. If she has 3.25 meters, and 1 meter is 1,000 millimeters, right? Then we're going to multiply this 3.25 by 1,000. So we get 3, 2, 5. Oh, this tablet. I'm going to have to change my tablet, I think. And we're going to move the decimal 3 places, so we have to add a 0 here. So that's 3, 2, and then if we're doing centimeters, we're going to move it twice because we're multiplying by 100. So that's 325 centimeters. Okay, and that's where we want to go because they're talking about 5 centimeters over here. So where we need to be, 3.25 meters is the same as 325 centimeters. Okay, so we kind of changed the question. She needs to make 100 tags. Each tag is 5 centimeters, and she has 325 centimeters of ribbon. Exactly how many more does she need to make 100? So if she needs to make 100, she needs to make 100 tags, and each takes 5 centimeters. So she needs 500 centimeters to actually do this. She only has 325. So that's what we need to do, is subtract 325 from there. Okay? And when we do that, we get 175. Okay? Which turns out to be A. So we had to do a unit conversion from meters to centimeters, figured out the total we needed, okay? And then to do that. We could have done it, left it in meters, 3.25 meters. If she needs 100 tags at 5 centimeters, that's 5 meters. So 5 meters minus 3.25 meters is 1.75 meters. And if we do the conversion again, 1.75 meters is the same as 175 centimeters, right? And it's asking for more. So that's why we do that subtraction from the total that needs to be done minus the amount of ribbon that she has already, okay? So this becomes just a unit conversion problem. And again, if you just remember 1 of something equals 1,000 milli-somethings, then all the rest should just fall into place. Okay, the sign below shows the length of the trail park. So the sign says, and we look at illustrations first. Sunrise Trail. It implies it's in 3 1/4 miles. Okay. So the reference sheet, if you remember, said that 1 mile is 5,280 feet, but you should have that memorized. So you should know that already. All right. So basically what we have to do is just do the 5,280 times 3 1/4. So for some of you, once you see that that's what it is, you know the answer can't be A or B. Okay? Is it C? If we have 5,280 just times 3? Well, 5,000 times 3 is 15,000. So is it 280 times 3? Is that going to give you the 840? Yeah, but what about the quarter? So you can see without even actually doing this calculation that the answer would be D. All right? And depending on how you want to do this, you can convert this to 12/4. And do 5,280 times 12/4. Sorry, whoop, I made a mistake. This is 13/4. So you'd have to do 5,280 times 13 divided by 4. You could also make 5,280, divide that by 4 first. 4 goes into 4 one time, and 4 goes into here. You're going to get 1,340, I believe. You guys could spot check me on this, and then multiply that by 13. All right, and that's your double check to get the same answer. All right, so that's 44. So this one's pretty straightforward. It's just a matter of trying to say, wait, are they really saying what they're saying? And yeah, sometimes the problem's straight up forward like this. Okay, this one delves into the concepts of math probabilities and statistics. And again, it's not the easiest problem in the world to understand. And then once you understand it, the math still gets a little weird on this. So we're going to take it the same way we said before. We're going to read the intro sentence, and then we're going to take it a bullet at a time. And then, as usual, there's a thing down here. And it's sometimes worth peeking at that. Which statement describes the product of the two numbers? What two numbers? Were they talking about a first number here and a second number there? So let's start over from the top. In a math game, a player chooses two numbers. So two numbers are chosen as described below. The first number, a mixed number between 2 and 10. This is math terminology. Do you know what a mixed number is? If you don't want to know what a mixed number is, you can't possibly get the answer right. Okay? A mixed number is a whole number, like 3, with a fraction. Okay? It's not a whole number. Okay? The second number is 1, 2, 3, 4, or 5. They're integers. They're counting numbers, they're whole numbers, there's various categories of them. They're not flip-flop and there's no decimal to them, at least of any significance. For instance, you could say 5 is the same as 5.0. It's still the value of 5. It's talking about 5 whole things, okay? So the second number is a whole number. The first number is not a whole number. It's a whole number with a fraction part. So it's 3 1/4. It's 9 and 7/8, right? And then it says it's between 2 and 10. So it does not include exactly 10. So it's like 2.01, right? Up until 9.99999, that kind of a thing. So it does not literally include 10, and it does not literally include 2. And it can't because it says they're mixed numbers. You could argue we could have like 3 and 0/4. So if we had 2 and 0/4, it's the same as 2. That's not really what they're intending here. You have to use some common sense too, even though the question does have a slight vagueness to it, okay? So what is going on here? What could they possibly be trying to figure out here? So we have the first number, something like 3 1/4. The second number is literally 1 or 2 or 3 or 4 or 5, okay? So now it says, which statement describes the product of the two numbers? Okay, so A, the product must be a whole number less than the second number. The product must be a value less than the second number. The product must be a whole number greater than the second number. So there's 2 criteria here in each answer. And by the way, this is not always the case, but it is in this one. So it must be a whole number, first of all, and then it must be less than the second number. Okay. In the second case, the product must be a value less than the second number. So that's just the criteria there. Okay, and the next one, the product must be a whole number that's greater, right? And the next one is the product must be a value greater. Okay, so in one case, they're looking for whole numbers and then some second criteria. And B and D, they're only looking for the second criteria. Okay, so let me get rid of that little squiggly line I just did. Just trying to show you that sometimes they break down the answer choices almost in like a table. Whoops, what did I just do? And sometimes it goes A and B is the same, and C and D are similar, or sometimes like A and C are similar, and B and D are similar. So let's just take this in turn, and they're forcing us to analyze each choice here. And I often like to go past, like let's say we determine the answer is A, I will still check B, C, and D just to be sure I just didn't misunderstand some aspect of it, okay? So the product must be a whole number less than the second number, okay? Well, if I take the choice I made, like 3 1/4, and I assume that the second number is 2, okay? Well, let's even take 1. 3 1/4 times 1 is not a whole number. So right there, the answer has to be wrong. It can't be A, okay? And it's less than the second number. Well, if I use 3 1/4 and 1, 3 1/4 is greater than the second number. So this fails as well. So choice A fails on both of the aspects that they're asking us about. B, the product must be a value less than the second number. Well, I just showed you a case that if the number was, say, 3 1/4 and 1, that the product would be 3 1/4. Well, that's greater than the value of the second number, which is 1. 3 1/4 is greater than 1. So B is out as well. Okay, C, the product must be a whole number. Well, we already determined in A that the product doesn't have to be a whole number. Okay, it could be. For instance, the first number was 3 1/2, and the second number was 2. That gives 7. But in the case of 3 1/4 and 3, then the answer is 9 3/4. So it's not a whole number. And would it be greater in that case? That would be true, but the first part is already false. So it seems the only choice left is D, so that better be true. So the product must be a value greater than the second number. So we've seen in all the cases that that's true. Is there a case where that's not true? Well, we have numbers here that are greater than 2 and less than 10. So let's pick 5. 5 times 5 is 25, right? And by the way, it says it must be a mixed number. So let's take 5 1/2, right? 5 1/2 times 4 is 11, or is 18 or whatever, right? 5.5 times 2 is 11, and 2 times 2 is 22. So is that value greater? Yeah. So there's all cases. This would only be false if one of the numbers was, say, a fraction or something under 1. Okay? And they're all positive, so I'm not even going to worry about that at the moment. We're not looking at negative numbers here. So the answer here is unequivocally D. First of all, it's the only choice left, so we did it through the process of elimination. But you don't want process of elimination to be left with a choice that you don't understand. All right? So you're going to use test values and experiment and actually see to make sense of it that all the test values work. And then you can apply the logic to it. That if the first number is greater than 2, and by the way, less than 10, and the second number is a whole number, then the value has to always be greater than the second number. It has to be. Because this has to be 2, 3, 4, 5, 6, 7, 8, 9. And 2 to 9 times one of these has to be a number greater than one of those. So we can apply logic to it as well, all right? All right, here's the next question. Okay, why is that blank? Oh, here we go. And let me just check again that we're live. Yep, we are. All right, I still see a bunch of people in the lobby. Greetings. What's up? What's up? What's up? Everybody's quiet. That's cool. If you want to talk, please talk. Just try to focus on the topic we're at. You can ask questions that are not about what I'm talking about, and I can answer them at the very end or email you directly. So what is the value of the expression below? So in this case, the illustration is strictly a value there. Okay, so any number is itself over 1. Okay, so 56 is the same as 56 over 1. And then this says divided by 1 over 17. Okay, so first of all, some kids are not going to look close enough, and they're going to think that's a plus sign. That's actually a division sign. Okay, so on your test day or your exam day, or you're just playing around with something, always make sure you know what's going on there. Okay. The second thing is some kids are going to make this equal to 56 over 17. Okay. That's not what this is. So that's false. That's not mathematically sound. That's not a way to do this. So this is 56 divided by 1/17. So when you see that, what you do is you convert this to multiplication, and you take the reciprocal of 1/17, which is 17 over 1. So what we have is 56 over 1, because this drops down straight. So we have 56 over 1 times 17 over 1. The over 1s don't matter. So what we really have is 56 times 17. Okay? So that pretty much rules out A, B, and C. Okay? And you want to double check though, but this is really the only choice left. But if we did 56 times 17, you get the 952. And as a double check, remember you can also do 17 times 56. And you should also be getting the 952. Okay, anybody who can't do that, please email me so we can figure out what you may have done wrong. If you do that calculation, you can't get 952, take a screenshot of it, send me a photo from your phone or whatever, and I could work through and tell you where you got the error at. Okay, but so number 9, like we showed some of the other ones that were pretty lengthy and a lot of details. Number 9 is a 10-second problem. 56 divided by 17. Oh, it's the reciprocal. We flip it over. So we change the division to multiplication. We get the reciprocal. So it's 56 times 17. Can't be A, can't be B, can't be C, got to be D. Okay? And you can even estimate that, right? That 50, if we round it off, we do 50 times 20, we get 1,000. So we have kind of a sloppy way to double check this as well. Let me just make sure how much time we're using here so far. We're about an hour. Let me see how far we've gotten on this. And we're not halfway yet. So let me do a couple more. And we'll probably call this a day and then do a part 2 either later on today or tomorrow or whatever. Okay. The plot line. What's a plot line? It's that illustration right there. So by the way, we're going to look at the illustration first. This one has a title, Eggs Laid by One Hen. Okay? And then it's telling us this is weight in ounces. So the numbers we're seeing on that quote number line thing means that. And the X's above some of the numbers means the number of times that happened. Okay? So it says the eggs laid by one hen. So first of all, an X represents one egg. Okay? And we can figure out its weight by under which number it's above. Okay? So if we take 2, there's 2 X's above 2. That means there were 2 eggs laid by that one hen that were 2 ounces each. There were 4 eggs laid by that one hen that was 1 3/4 ounces, right? Because this is 1 1/2 and this is 2, then this here is 1 3/4. Okay, this here is going to be 2 1/4. Right? Again, we're only looking at the illustration file. We don't know what the question is going to ask us. We're just analyzing this. And even though I talked this through with you guys, sometimes this is 2 seconds to actually do this yourself. Okay, and don't do it to the point where you're being sloppy, but do this analysis. Try to understand it without the question. And normally you're going to get what the question is going to eventually ask you in 9 out of 10 times just by analyzing this. The downside to doing it this way is sometimes you can over-analyze what it's asking you to do and end up kind of answering a question that they're never going to ask you about. But that's the little trade-off here. But I'd rather understand the illustration, because what happens is a lot of kids start getting thrown off by the words and then going back to the illustration. In the meantime, they never took the time in the beginning or during or after to figure out exactly what the illustration even meant. All right? So now that we understand this is about the egg-laying situation from one hen, and we analyzed it, so there's 1 egg that's 2 1/2 ounces, right? And so on and so on. So let's go back to the beginning. The line plot shows the weight of 10 eggs laid by one hen. Cool. We looked at that. What is the total weight in ounces of the 4 heaviest eggs? Whoa, 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 whoa. What are they talking about here? What do they mean, the 4 heaviest eggs? What are the 4 heaviest eggs? Okay, it turns out that if each X represents an egg, that this plus these 2 eggs is the 4 heaviest. For each, I'm going to put for each E. These are the 4 heaviest eggs. All right, so what we need to do is add them up. We need to add them up. There's 2 eggs here, so this represents 4 ounces. Okay, this is 2 1/4 more. So now between that we end up getting 6 1/4, and then we're going to add 2 1/2 more. That's sloppy. Let me write that over. Right, we're going to add 2 1/2 more. So we're going to end up with 8 3/4, which is D. Okay, when we do that. This all didn't fit on the page, but all right. So this one's pretty straightforward. What's really the key here, even though a lot of kids get this wrong, is realizing that each X represents 1 egg, and that there's 2 X's above 2. So that's 4 ounces. A lot of kids will do 2, 2 1/4, 2 1/2, and get 6 3/4, which is not one of the answers. and then not know what to do. And some of them will choose B just because of that, okay? And some will forget there's kind of a brain fog here where instead of some kids making this 2 1/4, they're just going to see 2 here. A lot of kids are going to just go 2, 4, 6.5. Oh, wait, I have to add the other egg in there? That's 8.5. And then they'll end up getting C, which is wrong. So again, it's worth, as I said earlier, label everything. Think it through, think it through. Take your time. You have to do things on a certain timeline and pace yourself on a test like this if you're taking a test, right? But we want to concentrate just on problem solving today, not trying to beat the clock here. Okay, let's do one more. So the table below lists the capacity in quarts for 4 different fish tanks. So we're going to look at the table. It's labeled again, cool. So this is capacities of fish tanks. Tropic is 120, Bahamas 60, Pacific is 240, fresh, and again it's in quarts. Okay, so this is pretty obvious. How big is tropical? Tropic, it's 120 quarts. How big is Bahama? It's 60 quarts. So it says which fish tank has a capacity of 60 gallons, but this is in quarts. Okay, so enough kids are going to say Bahama, but that's not the answer. Right? It's quarts. So again, if you go back to your conversion table, which was that bugger, we see here that it says a gallon equals 4 quarts. So therefore, a quart is a quarter of a gallon. That's why it's called a quart. 1 gallon is 4 quarts. If we divide both sides by 4, it means a quarter gallon is a quart. Okay? Let me go back to the other page. Where did that up? Here. We did that. So to get these in gallons, we basically divide each by 4. So that means this is 60 gallons. This is 15 over 4 gallons. This is 40 gallons. Sorry, this is 30 gallons. Right? And this is going to be 15 gallons. So again, this would be 15 over 4. Which is like 3 3/3. Okay, so that doesn't help us. So which is 60 is Pacific. So we get A. All right, so be careful. So this wasn't so much a hard problem, is that you need to know your unit conversions, right? And by grade 5, you should have learned them years and years before that. Okay, this doesn't quite fit on the screen. I could shrink it down, but I'm going to leave it as is for now, and we're just going to process it. We're going to look at the illustration first. This is the computers that are donated to a school. There's a company on the left hand. There's company name A, company name B, company name C, company name D. Company C gave 25 computers, as that says the number of computers. The number of computers what? Well, the whole thing is about donations. So company C donated 25 computers. Okay. Often in things like this, sometimes you have to do a tally. You would add all these numbers up, and down here you would produce the tally. Okay. We don't know what the question is yet. I like to do it often anyway. So we get 60, 70, 80. I believe the answer is 120 here. Let me do that a second time. 55, 65, 75, 80. Yep, the answer is 120. So this is total. Total D I'm going to put. Total donations. Okay. There's not really anything else they're giving us here, so there's nothing really to conclude or not from this. It's hard to say. All right, so let's go back and see what's going on here. The table shows the number of computers donated to a school by each of 4 companies. Cool. So these are the 4 companies over here, A, B, C, and D. Okay? All right? All the computers donated were shared equally by 5 classrooms. Okay? So that to me means we're going to look at 120 divided by 5. And whatever that answer is how many each class gets. So each class is going to end up at 24. We don't know that that's what's going to ask you, but I'm just trying to analyze this in depth with you guys so that you're on board to what's happening here or not. Okay? Right? So it turns out if they equally divide the 120 computers by 5 classrooms, each class is getting 24. So now what they're going to ask, let me shift this up slightly now so that you guys, since you have a better understanding of this, let me just make sure it's going on your screens the proper way, because my screen real estate is all chopped up. Let me just shift that over a slight bit. Okay, yeah, you should be able to see all the choices now. Okay, so now what they're asking us is in the form of an expression. Which expression represents the number of computers in each class? So they're actually not looking for the 24. They're just asking us, if you were to write an expression to solve this, what would it look like? Okay, so I kind of almost already showed you over here by doing this. So it's going to be the total basically divided by 5. All right, so 120 was the total, and 5/4 is 100. This is equal to 1 1/4. Okay, that doesn't seem to be what they're asking for. They're not asking for 25% over. Okay, okay. B says so A is no good. B is 120 times 1/4, or basically 120 over 4. It's not over the number of companies. There's 4 companies, but they said there were 5 classrooms. So it's not B either. Okay. C gets closer to it, but it's a misunderstanding. So C is just out. It's just the total number of computers times 1/5. 1/5 is each classroom. 1 over 5, which is the same as T over 5. So for that reason, the answer would be D. Okay. Okay, so we have a word problem, intermixed with mixed fractions. So this is a running theme for this grade 5 situation that we're being given kind of things like this. All right. So we're going to take it a sentence at a time, and within that a phrase at a time. To feed his plants, Logan creates a mixture that requires 3/8 of a cup of plant food for every gallon of water. So that's basically a ratio. So 3/8 per, and we use this little dot thing, per gallon. 3/8 of a cup to 1 gallon. Okay. If 10.5 gallons were used, what is the total amount of plant food that it needs? So we're basically looking at how many cups would be to 10.5 gallons. Okay, so I wrote that as ratios, right? So another way to look at this is 10.5 divided by 3/8. Okay. Oh wait, sorry, times 3/8. So 10.5 is the same as 10 and 10. Let me write it as 10.5. So that's equal to 21 halves, right? So we're going to take 21 halves times 3/8. And we're going to get 63 sixteenths. So if you know the multiplication table, 16 times 4 is 64. So this is going to be equal to 3 and 15 sixteenths. Okay, which turns out to be A. Right? If you notice, I made a goof up here. I originally said it was division. What's not important is that you made the mistake, is that you can fix it right away. All right? These problems weigh you down, and they can be tricky at times and stuff like that. Just the key is to understand what I set up here originally, what the relationship between the different things are. And then from there, you can figure out which way to go with it. Okay? So he creates a mixture of 3/8 of a cup for every gallon of water. There's 3/8 per gallon. So if there's 10.5 gallons, it's multiplication. It's 3/8 times 10.5. If 3/8 is used for 1, then it's 3/8 times 10.5 for all the whole 10.5. All right, so that's that. All right, so we're about halfway through with these problems. Let's see, how are we doing on the timeline? Yeah, we're already an hour and 15 minutes. So what I think I'll do is a part 2 to this at some other point. Hopefully you guys are getting something out of this. Please email me if you need any help. I wish you guys luck for the New Yorkers and other states who are having their state test tomorrow. Please subscribe to the channel. I always do different ones of these. I normally am focused on the essays, SAT, and other such things, but I also do spin-offs on the various topics like this. I'm trying to give kids a lot of heads up. Again, I define hardest as problems that a lot of kids got wrong on the state test in past years. There are other ways to define hard. I tried to make this topic and concept and problem solving based, even though we're using concrete examples like this. I'm just trying to give an overview of hardest problems. I'm not starting from 0 and teaching you all of grade 5, right? All right. Again, I'm Greg from GregsTutoringNYC at gmail.com. Please subscribe and like, and peace out. Have a good day. And I'm going to do a part 2 to this, maybe even later, but definitely tomorrow. Peace out.